are solving the arithmetic progression. My second question is the geometric progression, which we get from the paper 2 question. My second question, which is the geometric progression, states in a geometric progression, the third term is 2 over 9 and the fourth term is 2 over 27. Find A, the first term and the common ratio, and 2, the sum of the first 5 terms of the geometric progression. Then the last question says sum to infinity. So here I'll start with finding the first term and the common ratio, which will be my first question. So finding the first term, we have to list what we have here. So the third term of an arithmetic progression is 2 over 9. So the third term is equal to a r to the power 2, which is the third term. The third term, which is equal to over 9. Then we have the fourth term. The fourth term is also be so this a r to the power 2 is the same as the third term. Then a r to the power 3 is the same as the fourth term. So here to find the first term and the common ratio, we first find the common ratio. After finding the common ratio, we'll be able to find our first term. So here we have to find common ratio, the formula we use normally is R is equal to T2 divided by T1. So here we have this will be our T2 and this will be our T1. So we place this information on equation. So we have so here we have, this is our T2 and this will be our T2, this will be our T1 and this will be our T1. Here we divide R3 divided by R. As indices states, if the bases are same, when dividing you subtract the powers. So here we have R3 minus 2 is equal to, here we have this will divide this into this, which will make, we'll swap this and this will exchange. This division will change to a multiplication sign. Then the 2 and the 9 will swap. So we have 9 over 2. Then here are R to the power 3 minus 2 will subtract 3 minus 2 is 1, which will be the same as R. Then here we divide the things which can divide. So here we have 2 into 2, we have 1. Then 9 here, 1. 9 into 27, we have a 3. Then 1 times 1, we have 1 over, then 3 times 1, we have 3. So here we have found our common ratio, which is 1 over 3, which will make it easier for us to find the first term. So here, what we'll do, we can choose either this equation or this equation to find the first term. As for me, I'll use the first equation so that I can find the first term which is stated in the question. So we have this equation, which is A to find the first term, I'll choose this equation, the first equation, which is A r to the power 2 is equal to 2 over 9. Since I have my common ratio here, I'll replace this r with this common ratio. So I will write my equation. Over 9. So that's how my equation will be. So here I need to evaluate this to get a single number. So here multiply this to the power. So we'll have A, then 1 over 3 to the power 2 will have 1 over 9, which is equal to 2 over 9. Then this is the coefficient for A, meaning that we have to divide both sides by this, even this side by this. So here we have A, right. Then this and that will remain with the A. When we reach here, this sign changes to multiplication and 1 and 9 swap. So we have 2 over 9 times 9 over 1. Here we'll divide the numbers which can divide. So we'll have 9 here, 1, 9 here, 1. Our A equal to 2 times 1, which is 2, over 1 times 1, which is 1. Our A will be equal to 2 divided by 1, we have 2. So we have found our first term and the common ratio. The second question says, find the sum of the first 5 terms of the geometric progression. Finding the sum, we use this formula, which is here. Using this formula, it depends on the common ratio which you have. If the common ratio is less than 1, we use this, but if the common ratio is greater than 1, we use r minus 1. But here the common ratio is less than 1, so we use 1 minus r. So on this equation, we distribute what we have according to the question. So we'll have the finding the sum of the first 5 terms, which is equal to, here A will use the first term which we have, which is 2, then 1 minus our r, we have 1 over 3. The power n comes from the 5 which we have been given in the question, which our n is 5. Then down here over, have 1, then the r is still the common ratio which we have, minus 1 over 3. So here we have distributed the information in the equation. We now solve. We have S, the sum is equal to 2, then 1 minus, then we multiply this common ratio to the power. So we have 1 over 3 to the power 5, which will be 1 over 243. 243 over 1 minus 1 over 3. We'll also subtract this part which is down. We have 1 minus 1 over 3. We'll have 2 over 3. Then after that, we'll subtract this from this, which will be 1 minus 1 over 243 will have 242 over 243. Then over, we still have this equation, we bring it down, this number, we bring it down again, have 2 over 3. At this stage here, we multiply this number with these numbers in the brackets. So here we'll have sum of the first 5 terms is equal to 2 times. So here we'll have multiplied these 2 times these numbers inside. So 2 times 242 will have 484. Then 2 times 243 will have 486. Then this means we have to divide this 2 over 3 into this number. So our sum of the 5 terms will be equal to 484 over 486. This would divide, but after dividing the sign will change to multiplication, which will have to swap these numbers, meaning the 3 will be here and the 2 will be down. So multiply this times this and this times that. So our multiplication answer will have to multiply this times this and this times this. So 484 times 3 will have 1452. Then 486 times 2 will have 972. After this, we divide this into this. So our sum of the first 5 terms is equal to, so 1452 divided by 972 will have 1.49. So this will be the sum of the first 5 terms. So after finding the sum of the first 5 terms, we go to the last question, which says find the sum to infinity. My last question says the sum to infinity. So here we are finding the sum to infinity. Sum to infinity has the equation which is so sum to infinity is equal to a over 1 minus r. The a we use is the first term which we found in the first question, and the r is the one which we found in the first equation. So sum to infinity will be our a was 2 over 1 minus. Our r was 1 over 3. So sum to infinity is equal to 2. Then you subtract this from this, so have 1 minus 1 over 3, which is 2 over 3. Here, meaning that this has to divide into 2, which will be equal to 2 over 3. So this sum to infinity will be equal to 2 divided by 2 over 3. This sign here has to change to a multiplication sign, while the 3 and the 2 change places. So here it will be the 2 here will be over 1 times 3 over 2. So our sum to infinity will be equal to, we'll multiply 2 times 3 will have 6, then 1 times 2 will have 2. So here it will be 6 over 2. Our sum to infinity, we'll find it by dividing this 2 into this 6. So it will be 6 divided by 2. So sum to infinity. So our sum to infinity will be equal to 3.